Namaste students. Today we are going to study lesson number 6, Refraction of Light from Science and Technology Part 1. I am Mrs. Lina Talathi from Deccan Education Society's Madhav Sadashiv Golwalkar Guruji Madhyamik Vidyalaya. Let's see the lesson through PPT. Lesson number 6, Refraction of Light. Points to remember: refractive index, laws of refraction, and dispersion of light. Can you recall what is reflection of light? What are laws of reflection? How are shadows formed? What is reflection of light? When light rays fall on opaque and shiny surface, their direction changes and they turn back in the same medium. It is called reflection of light. Shiny surfaces are like stainless steel, mirrors, etc. What are laws of reflection? The angle of incidence, angle of reflection, and equal or normal lies in a same plane. Second, angle of incidence, angle of reflection are on the opposite side of normal. Third, incident ray I and reflected ray R of the same measure. So, angle I is equal to angle R. How are shadows formed? When any opaque object comes in the path of light, it casts a shadow on the opposite side. That is, the straight light rays or straight rays of light passing the edges of non-transparent opaque body leave a sharp shadow of that body in the way of light. Examples of mirrors: spherical mirrors. This is concave mirror. This is convex mirror. This is convex mirror. This is convex mirror, and this is plane mirror. Image formation in mirrors. This is the plane mirror where image form is exactly behind the mirror at the same distance. This is concave mirror where the image is bigger, and this is convex mirror where the image is smaller. Refraction of light. Now let's see the example of refraction. Let's carry out activity. This is the activity 1. Here you have to take glass which is half full with water. Now dip a pencil in a glass. We will able to see that pencil is broken. Actually, the pencil is not broken. Here, this effect is seen due to refraction of light. Second activity, take a glass of water, dip one coin in a water. We will able to see two different positions of coin. Actually, we dropped only single coin, but we can see two different positions of coin. Here, actually the coin is at the base, but this is the apparent position of coin which can be observed by this experiment. This is due to refraction of light. Now, let's carry out experiment to see how refraction takes place. We are carrying out the experiment to show refraction of light, for which we need a glass slab, pen, some pins, ruler, and a protractor. So, first draw an outline of glass slab, putting it in the middle of the paper. Then take a protractor and draw a 90-degree angle about 2 centimeters from left edge of the glass slab. So this is normal. Then mark 30 °C angle from the glass slab. So this is 10, 20, 30. So mark this and draw a ray to show incident ray. So this is angle of incidence I, which is equal to 30 degrees. This is normal N. PQRS is the name given to the glass slab. Now place 2 pins on this ray and replace the glass slab. Observe from this side and see the straight line. On this straight line we have to place 2 another pins. So observing from this side, we will put the pins mark the pins, mark the places of pins, then remove everything. Join these places of 2 pins with the glass slab. Then draw a normal at this point. You will able to see that the actual path of incident ray is like this. But joining this point of refraction and point of emergence, we will able to see that the ray which is incident on the glass slab changes its path while traveling through the glass slab and comes out to the different path. Now let's measure this angle, that is angle of refraction R. So R is equal to 17 degrees and angle of emergence E, which is exactly 30 degrees. So angle of incidence is 30 degrees and angle of emergence is 30 degrees, while the angle of refraction is 17 degrees. So the incident ray bends while traveling from the another medium, and again it bends when it travels to the second medium. So while entering from air to glass, it moves near the normal, and while coming out from glass to air, that is denser medium to the rarer medium, it bends away from the normal. Light changes its direction when going from one transparent medium to another transparent medium. This is called as refraction of light. The diagram will look like this. Here, AB is a incident ray, then NM is refracted ray, and MD is emerging ray. I is angle of incidence, R is angle of refraction, and E is angle of emergence. So I and E are of equal measure, while I is greater than R and R is smaller than E. That means from air to glass, when light rays enter, they pass through the glass slab, through the denser medium, and turns near the normal. When that comes out, that is from glass to air, that goes away from the normal. This is a picture which is showing actual light ray passing through the glass slab. This is the light source. When that light ray passes through the glass slab, it comes out through the different direction. The direction is changed. Difference between reflection and refraction. First point, reflection takes place from opaque medium. Refraction takes place through transparent medium. Second point, light returns back in the same medium in case of reflection. Light travels through two transparent medium in case of refraction. In case of reflection, only one medium is sufficient to carry out this phenomena. In case of refraction, minimum two different transparent media required to take place this phenomena. Reflection, angle of incidence and angle of reflection are of same measure, while in case of refraction, angle of incidence is greater or smaller than angle of refraction depending on the medium. Why the velocity of light in a glass slab is less than that in the air? Can you think? Because the glass slab is a medium which is denser. Air is a medium which is rarer. So in the rarer medium, velocity of light is greater, and in a denser medium, velocity of light is higher. Now let's see laws of refraction. Incident ray and refracted ray at the point of refraction are on the opposite sides of normal. Incident ray, refracted ray, and the normal lie in a same plane. For a given pair of media, here it is air and a glass, the ratio of sin I is to sin R is constant. Here I is equal to angle of incidence and R is equal to angle of refraction. So sin of angle of incidence divided by sin of angle of refraction is nothing but constant. Now what is refractive index? Refractive index is equal to sin I upon sin R, which is equal to n. N is constant. Refractive index depends on the velocity of light in the medium. The refractive index of a medium with respect to vacuum is called as absolute refractive index. N is called the refractive index of second medium with respect to first medium. This is called as Snell's law. So, refractive index of second medium is to first medium is equal to velocity of light in medium 1, that is V1, divided by velocity of light in medium 2, that is V2. Similarly, refractive index of first medium with respect to second medium is equal to V2 upon V1, that is velocity of light in medium 2 divided by velocity of light in medium 1. Refraction of light in different media. When light passes from rarer medium is to denser medium, it bends near the normal. When light ray passes from denser medium to the rarer medium, it bends away from normal. It bends away from normal. When a light ray is incident normally at the boundary between the two media, it does not change its direction. It passes straight as it is and hence does not get refracted. Twinkling of stars. Here we can observe twinkling. Can you see the stars are twinkling? Why this happens? Star is a point source. They are self-luminous and seen at night in absence of sunlight. As we move about the surface of the earth, density of air decreases. We are near the earth's surface, so density of air increases compared to the layers at high altitude. The starlight coming from the star towards us travels from the rarer medium to the denser medium and constantly bends towards normal. So stars appear to be higher in the sky as compared to its actual position. But planets do not twinkle. Planets are not self-luminous. They are not point sources as well. They obtain light from stars and reflect it. They are comparatively nearer than stars. So, planets do not twinkle. Mirage. Due to the change in refraction of light, the light rays coming from a distant object appear to come from the image of that object. Earth's surface is heated by the sun. The temperature of air increases. This produces layer of hot air with less density, so refractive index is also low at that surface. When the temperature changes rapidly in the vertical direction as refraction of light takes place, the angle of refraction changes continuously. Hence, an inverted image is formed below the object's true position and downward towards the surface in the direction of air at higher temperature. In this manner, mirage produces an impression of water near the hot ground. This phenomena we can observe near holy fire or in deserts also. Early sunrise and delayed sunset. Early sunrise is also called as advanced sunrise. It is due to atmospheric refraction of sunlight. An observer on the earth sees the sun 2 minutes before the sun reaches the horizon. A ray of sunlight entering the earth's atmosphere follows a curved path due to atmospheric refraction before reaching the earth. This happens due to a gradual variation in the refractive index of the atmosphere. For the observer on the earth, the apparent position of the sun is slightly higher than the actual position. Hence, the sun is seen 2 minutes before it reaches the horizon. Is called early sunrise. Similarly, if observer on the earth continues to see the setting sun, he can see it for 2 minutes after the sun has dipped below the horizon. Is called delayed sunset. Dispersion of light. So the process of separation of light into its component colors while passing through a medium is called as dispersion of light. Sir Isaac Newton was the first person to use a glass prism to obtain sun's spectrum. The wavelength of radiation to which our eye is sensitive is between 400 and 700 nanometers. 1 nanometer is equal to 10 raised to minus 9 meters. We get 7 colors after dispersion. They are red, orange, yellow, green, blue, indigo, and violet, out of which red bends the least and violet bends the most. Wavelength of red color is about 700 nanometers, while wavelength of violet color is about 400 nanometers. Therefore, signals are red in color. Dispersion of light. Here, this is a light source. This is a prism kept in front of it so that to get a spectrum on this side. This is the color spectrum that is observed with the light source. Partial and total internal reflection. When light enters from the rarer medium to the denser medium, it gets partially refracted. That is, with refraction, some light also gets reflected and comes back into the denser medium as per the law of reflection. This is called partial reflection. As light is going from denser medium to the rarer medium, it bends away from the normal. Angle of incidence I is smaller than angle of refraction R. If we increase I, the angle of R also going to increase. Then at certain value of I, the value of R becomes equal to 90 degrees. That is, the ray travels parallel to the surface of the medium. This is called as critical angle. That is, for particular value of I, the value of R becomes equal to 90. This is called critical angle. If I is increased further, there is no refraction, all light gets reflected. So, there is no refraction of light, all the light enters water again, no refraction takes place. This is the total internal reflection. Formation of rainbow. Beautiful natural phenomena, combined effect of dispersion, refraction, and total internal reflection. The formation of rainbow in the sky is a combined effect of refraction, dispersion, total internal reflection, and refraction again. Sunlight by water droplet undergo total internal reflection and comes out as refracted ray. While coming out, it will get separated into 7 colors. They are Vidyalaya. After it has stopped raining, the atmosphere contains large number of water droplets. When sunlight is incident on these droplets, there is refraction and dispersion of light. As it passes from air to water, total internal reflection of light in the slide, the droplet and refraction of light as it passes from water to air again. The refractive index of water is different for different colors, being maximum for violet and minimum for red. Hence, there is dispersion of light as it passes from air to water. The combined effect of different water droplets acting like tiny prism is to produce a rainbow with red color at the outer side and violet color at the inner side, and remaining 5 colors lie between these two. The rainbow is seen when the sun is behind the observer and droplets are in front. Now let us see some numerals. The absolute refractive index of water is 1.36. What is the velocity of light in water? Velocity of light in vacuum is 3 into 10 raised to 8 meters per second. Given V1 is equal to 3 into 10 raised to 8 meters per second, and N, refractive index, is equal to 1.36. Formula: N is equal to V1 upon V2. Placing the values in the formula, we get 1.36 is equal to 3 into 10 raised to 8 divided by V2. So V2 will be equal to 3 into 10 raised to 8 divided by 1.36. So value is 2.21 into 10 raised to 8 meters per second. Second, light travels with a velocity 1.5 into 10 raised to 8 meters per second in a medium. On entering second medium, its velocity becomes 0.75 into 10 raised to 8 meters per second. What is the refractive index of the second medium with respect to the first medium? Given V1 is equal to 1.5 into 10 raised to 8 meters per second. V2 is equal to 0.75 into 10 raised to 8 meters per second. Formula: N is equal to V1 upon V2, which is equal to 1.5 into 10 raised to 8 divided by 0.75 into 10 raised to 8. The value is 2. If the speed of light in a medium is 1.5 into 10 raised to 8 meters per second, what is the absolute refractive index of the medium? Given speed of light in a medium equals to 1.5 into 10 raised to 8 meters per second, speed of light in the vacuum is equal to 3 into 10 raised to 8 meters per second. Absolute refractive index is equal to of medium 1:2 is equal to V1 upon V2. So that is equal to 3 into 10 raised to 8 divided by 1.5 into 10 raised to 8. That is equal to 2. Thank you, students. Today we have seen refraction of light, in which we have seen reflection, refraction, how early sunrise and delayed sunset is seen, how rainbow is obtained, how refraction is taken place by glass slab, and so. I think you have understood the lesson. Thank you.